students, today's lesson is on parallel lines and transversals. Before we get to those topics though, let's go ahead and review some vocabulary that you should already be familiar with. Complementary angles are two angles that add up to 90 degrees. They could look like this picture where they make up a right angle and the right angle is bisected, or it could just be two angles that aren't even next to each other that happen to add up to 90 degrees. Those are complementary. Supplementary angles are two angles that add up to 180 degrees. So it could look like this picture where you can see that they are supplementary angles because they add to 180 degrees and make a straight line. Or it could be just two angles that happen to add up to 180 degrees. Adjacent angles are two angles that are right next to each other. So they share a common side, in this case, line BC. And they also share a common vertex. So vertex B is in common between those two angles. And then vertical angles are a pair of non-adjacent angles that form when two lines intersect. So here we have this picture of these two black intersecting lines. The blue angle and the green angle are vertical to each other, and they are congruent. All right, a little bit more vocabulary here. Parallel lines are lines that lie within the same plane that do not intersect. So what that means that they're in the same plane is they're on the same two-dimensional space. They're not two angles that are like on two different planes and don't intersect. They're on the same two-dimensional flat surface and they don't intersect. Perpendicular lines are lines that intersect at right angles. So hopefully those are familiar terms as well. This one might be a new one for you. A transversal is a line that intersects two or more lines. So here we have this line N that intersects both lines L and line M. Now in this case, it appears that line L and M are parallel, and that's going to be something that we look at in more detail in today's lesson. But a transversal can be a line that intersects any two or more lines. They don't necessarily need to be parallel for that to be the case. Corresponding angles is another word you're going to need to know for today, or another term. These are angles that occupy the same relative position at each intersection where a straight line crosses two others. So where you have that transversal coming through, the two angles that are like above the line and to the right of the transversal, so these red angles would be corresponding angles. Here we have the blue angles that are above the line and to the left of the transversal. Those are corresponding. The purple down here that's below the line and to the right are corresponding. And the green that's below the lines and to the left of the transversal. Those are corresponding as well. So we have four pairs of corresponding angles that are formed. Now, when that transversal comes through and intersects two lines that are parallel, so in this case, line P and line Q are parallel, those corresponding angles are going to be congruent. So if the lines are not parallel, the corresponding angles will not be congruent. But if the two lines that are intersected by the transversal are parallel, then the corresponding angles will be congruent. All right, so let's go ahead and get on with some examples here. We're going to use the figure to find the measure of angle 1 and 2. So we're given this 110-degree angle. And we can see from these little arrows on line A and line B that A and B are parallel to each other. That's what these little arrows in the middle of the line mean. And so because we know that these lines are parallel, this transversal, line T that's coming through, is going to create some congruent corresponding angles. So angle 1 is a corresponding angle to the 110-degree angle, and it's congruent because the lines are parallel, so therefore angle 1 is 110 degrees. So let's go ahead and write that. Angle 1 is 110 degrees, and we need to explain why, and we're going to say it's corresponding to 110 degree angle. And then to find angle 2, we're going to use what we know about supplementary angles. We see that line B is a straight line, and angle 1 and 2 would therefore be supplementary. So angle 2 must be 70 degrees. Supplementary to angle 1. All right, so let's go ahead and look at our next example. Here we have, again, two parallel lines, and we can see that from the arrows, and we have a transversal that's cutting that. So we want to use the figure to find the measures of all of the numbered angles. We could use a variety of different ways to find those measures, but let me go ahead and start by just labeling angle 1, angle 2. We'll fill in the measurements. Okay, so let's start with angle 1. We could say that angle 1 is a vertical angle to the 75 degree angle, so therefore it's 75 degrees. Vertical to 75 degree, oops, not 70, 75 degree angle. Okay, and then angle 2, we could say is supplementary to angle 1. It's also supplementary to the 75 degree angle. So therefore, it must be 105 degrees. Supplementary to angle 1. All right, angle 3, we can see is also 105 degrees. And we could say that it's vertical to angle 2. We could also say it's supplementary to angle 1. All right, now we want to use corresponding angles here. So for 4, 5, 6, and 7, let's use what we know about corresponding angles. So let's say that angle 4 and 1 are corresponding angles, so therefore angle 4 must be 75 degrees. Corresponding to angle 1. We'll say angle 5 and 2 are corresponding, so that must be 105 degrees, corresponding to angle 2. Angle 6 and the 75 degree angle are corresponding, so that one must be 75 degrees, corresponding to 75 degree angle. And 7 and 3 are corresponding, so therefore angle 7 must be 105 degrees. It's corresponding to angle 3. All right, a little bit more vocabulary here. Interior angles are angles formed on the inside of the parallel lines when two parallel lines are cut by a transversal. So here we have line P and line Q, which are cut by the transversal T, and the interior angles would be 3, 4, 5, and 6. They're all 4 angles that are inside between the two parallel lines. The exterior angles are the angles on the outside of the parallel line. So 1, 2, 7, and 8 would be the exterior angles. Here's one more key idea. When a transversal intersects parallel lines, the alternate interior angles are congruent and the alternate exterior angles are congruent. So let's take a look at the alternate interior angles. So here's 4 interior angles. These 2 red angles would be alternating from each other. One is to the right of the transversal, one is to the left. And same thing with these 2 double blue arcs here. One is to the right of the transversal, one is to the left. So those are alternating interior angles. Same thing with our alternating exterior angles. The ones that are to the outside of the parallel lines and on opposite sides of the transversal are our alternate exterior angles. Okay, is that it? Yeah, that is it. So go ahead and try a few of these on your own, and I will see you soon.